All right, let's get into it. Today, we're on a mission. We are going to take on that slow, bloated JavaScript bundle that's been holding your Next.js app back.
So you've done everything right. You're using this amazing framework, but you're still staring at a loading spinner that just seems to go on forever. It's a super frustrating problem, right? But the good news is it's totally solvable. And the answer? It's usually hidden in how your code is being bundled and sent to the user.
You see, every single kilobyte of JavaScript you ship has a real, tangible cost. It's not just a number. It actively blocks the browser's main thread, which means your users can't click on anything or interact with the page. This totally crushes performance on cheaper phones and honestly makes for a sluggish experience for everyone. So shrinking that bundle, it's probably one of the biggest wins you can get.
So where do we even begin? Well, let's start with the foundation, because Next.js actually gives you some really powerful wins right out of the box automatically.
This is your first line of defense. By default, Next.js is smart. It creates separate JavaScript files or bundles for each page. So a user hitting your settings page doesn't have to download all the heavy code for your dashboard. That's a huge advantage, but trust me, it's only the beginning.
Now, the biggest game changer in modern Next.js is server components. Here's the simplest way to think about it. Everything on the left runs on the server and ships zero client-side JavaScript by default. Zilch. All your heavy lifting, fetching data, talking to databases, it all happens on the server. The client only gets the code it absolutely needs for things like clicks and state. Getting this right is totally fundamental to building a fast app.
All right, so Next.js gives us a fantastic foundation. But to get that really elite level performance, we need to roll up our sleeves and take manual control. So let's open up the toolkit and see what we've got.
Okay, the main weapon in our arsenal is Next/Dynamic. Instead of cramming a component into the initial page load, this amazing utility lets us wait and only load that component's code when the user actually needs to see it.
So here's what it looks like in practice. We're just wrapping our big, heavy chart component in this dynamic function, and we're passing a couple of handy options. SSR is false, tells Next.js, hey, don't bother rendering this on the server, which is perfect for stuff that needs the browser. And then the loading prop lets us show a fallback, like a nice little spinner, while the real component code is being fetched. It's clean, it's simple, and it is incredibly powerful.
So what does this actually feel like for the user? Well, the initial page load is lightning fast. Then, when they click a button to see a chart, boom, they get instant feedback with a loading state. The chart's code is fetched quietly in the background, and then it just appears. The key here is that we didn't make them pay the performance price for that chart right at the beginning.
So, where should you use this? This slide is basically your cheat sheet. Think about anything heavy. Charting libraries, map components, rich text editors. Think about stuff only certain people see, like an admin dashboard, or literally anything that only shows up after a user clicks something, like a modal dialog. These are all perfect candidates.
And this gets to a really critical point. Even if you don't actually use a component, just having that import statement at the top of a file can be enough to pull a huge library into your main bundle. It's a silent performance killer that's so easy to miss.
This idea also applies to your own code. Come on, we've all seen that one giant utils.js file with 20 different functions. The problem is, if you import just one function from it, the bundler often has to include the entire file. By splitting your code into small, focused files, you make it way easier for the build process to do something called tree shaking and just throw away the code you're not using.
Okay, we've got our toolkit, but you can't fix what you can't see, right? So let's move on to part 3 and talk about the radar, the tools we use to actually find these performance bottlenecks in the first place.
Your first and most important tool is built right into Next.js. Just run your normal build command, but add the -analyze flag. This will generate a visual map showing you exactly what's inside your JavaScript bundles. For any serious performance work, this is absolutely non-negotiable.
And that map, it might show you something kind of shocking, like this. You could discover that huge libraries you barely even use, like all of Moment.js or the full Lodash library, are making up most of your bundle size. This kind of visualization immediately tells you exactly where to focus your energy.
Now, the analyzer is great at finding problems, but fixing them often comes down to this idea of writing tree-shakeable code. Tree shaking is just the bundler's process for removing unused code. But here's the catch. It can only do its job if you write your code in a way that helps it out. Here's exactly what that looks like. On the left, importing the entire Lodash library makes it impossible for the bundler to know what's safe to remove. But on the right, by importing only the specific debounce function we need, we give the bundler a crystal clear signal to shake out all the rest. This one-line change can literally cut kilobytes of junk from your bundle without changing any of your app's logic.
But we can actually take this one step further. A lot of modern libraries release an ES module version, which can usually spot by the -ES at the end. These are specifically designed for amazing tree shaking. Using them, like low-ES here, is really the gold standard. It gives the bundler the best possible shot at creating the smallest bundle.
The bundle analyzer is your key weapon, but it's part of a whole toolkit. You've got to combine its insights with tools like Lighthouse and Web Page Test to measure what real users will actually experience. Remember, you have to measure, not guess.
So we've covered the automatic optimizations, the manual tools, the analysis techniques. But what really ties all of this together? It's not just a set of tricks, it's a whole mindset.
If you only take away one thing, please let it be this. This is your new mantra. For every feature you build, ask yourself, can I ship less JavaScript? Can I ship it later? And do I only ship it when it is absolutely needed?
This is the complete philosophy. It's about being intentional. Let server components do all the heavy lifting, so you keep logic off the client. Break your code into small, splittable chunks, and use dynamic imports to put off loading anything that isn't critical for that first paint. This is how you build apps that aren't just fast today, but actually stay fast as they grow.
So, with all that in your head, I'll leave you with a challenge. Go run the bundle analyzer on your own project. Look at the map, apply this mindset, and then ask yourself, what's the first bottleneck you're going to fix? Thanks for tuning in.